Hello everyone and welcome to this next video in the series of tutorials for the CAD-NX practical course. Today we are looking into a rather easy part, especially compared to the ones that follow, and that's this bolt right here. But I think this especially is a very nice opportunity to show that you can model the same part in a multitude of different ways, and none of them is better or worse as long as your part in the end looks the same. The difference most of the times is just that it, kind of personal preference on the one hand, what you like more, and on the other hand, maybe some ways are quicker or more convenient if you immediately get the idea to use that specific way. So, but as always, if we want to start, let's have a look at our technical drawing and see what we have. We only have two different drawings right here, and one of those is a 3D image. It's always nice if we have a 3D image because we can see how the part should look in the end, and usually that's the first thing I want to have a look at. That one is a little bit confusing because we don't see this rounded tip on the head of this bolt, because it's kind of hidden from this edge. But however, I think you can imagine how it should look in the end. Also, if you're not sure, it sometimes even helps to read the name. Okay, it should be a bolt, and if you know what a bolt is, then you know if it makes sense what you see in that image. And then there's one more thing, and that's this line in the middle. And if you remember the technical drawing introduction, a line like this is a symmetry line, and in that case it can only be a line where, especially if it's in the 3D space, where the part is rotated around, okay? So that's already a huge hint and screams for revolving around this symmetry line. And what could we revolve? That is this sketch, but we only need half, of course, because if we want to revolve around this line, then our cross section that we want to revolve around it is not allowed to cross the line. So the line is not allowed to be within the cross section, and that's no problem because we only need this half, and if we rotate this half around the line, then we will end up with the right body. So that would be my first intuition and my first idea, and I think it should also be the fastest one, so let's do that first. So let me zoom so that I can see the whole drawing. Start a new sketch. I already started a model. You should know how to do that by now, I guess. And I'm choosing this right plane for no particular reason. It's not that important which plane you choose. What's more important, at least for yourself, for how easy it will be to model the part, is where you have your sketch origin. And in that case, one thing that is need to have is that this is the line that we want to rotate around to this x-axis. So our origin, of course, should be somewhere on this line, and then it's not that important where it should be, but I think the easiest would be just to have it here exactly, because, and if you want to think about in the beginning where to put the origin, it's always a nice idea to look at from which point there are many dimensions given. And from here you see we have this height of 5. From also here there's a length of 20, there's a length of 22, and then based on that you can add the other dimensions. So I think that it's a nice idea to use that as an origin. So I take the profile function and start in the origin, go up 5, zoom in, go up 5 on the axis, of course. And now I'm gonna draw the part without giving any measurements yet. We can do that later always. Like that. And now we need an arc. And for the arc, sorry for all the zooming. I wanna, okay, I exaggerated it a lot. Maybe let's undo it and make it a little more like in real life. Like that somehow. And then let's go back and close the sketch. Okay. And now we can start adding our dimensions. First of all, I think that this is a little bit big, and if you want to make that smaller, your dimensions, you can go on view up here and then on decrease. Or if you hold Control and click on the down arrow or the up arrow, you can also make this smaller and bigger. Okay, so now let's actually introduce our dimensions. The 5 we have. The next one could be this height between here and here. Let me click the 2. And that should be 0.5 only. Then this right here should be 1. As well as this should also be 1. If I read that correctly. Then we have this 20 from here to here. 20. Okay, that moved it a little bit weirdly, so let's drag that back out. We have 22 here. And then we have a height of this part of 2.5. So let's go from here and try to grab that. Yeah. And that should be 2.5. Nice. So far so good. What else did we miss? 2.1 for this dimension. Okay. And now, if you think you have everything in, like I do right now, you can check down here and it says sketch is partially defined. So I don't have everything in. And to find out what you still need to change, first thing that you can do is look at the at your program and at your sketch and look for brown lines. And all the lines are black, so that means they are defined apart from this one. This one is still brown. If I move it, that's the next thing that you can try. Move it around. Nothing moves. So it seems to me that the only thing that's not defined might be the center point right here. You see, if I clicked on the arc, then its center point appears, and then you can try to drag that around, and that's still possible. And but where does it need to be? We don't have that given. Well, what we have given is we want to rotate that around this axis, and if we rotate that, for example, like this, I hope you can imagine how that would turn out. Then it wouldn't be a smooth transition here, but it would be it would have this dent. Maybe I can show you very quickly, because this is a pretty crucial part, I think, that needs to be understood. So you see, now it looks like this. It's not going like perpendicular to the y-axis. And if I now revolve it and specify the y or this axis as a vector, you see, let me click OK. It looks like this, and that's definitely not how it should look like. Let's go back into the sketch. If we do it like this, for example, so if it's too steep, then it looks like this. Then it gets pointy in the end, okay? So, oh shit, let's go back to the sketch, sorry. If both are wrong, where does it need to be? Well, you might have already guessed before. Here it was with that little dent. Like this, it's too pointy, so it needs to be exactly on this line. Exactly on the same line as the start point. And therefore, if we now click on finish, this is perfectly round. Okay, that's the whole idea behind this part, and the only difficulty, I would say. Another approach of doing that, if you don't want to constrain the point to this line, you see here this circle around it, that means it's a coincident constraint. The point is coincident to the line. So let me show you a different approach of how to do that. And I'm showing this multiple times during this course, right here, because I think it's something that still, in the end, some students or many students don't understand, and it helps a lot to understand it, because sometimes that is a error that people make in class. So the second idea is, if we don't want to make this point coincident to the line on which this also lies, the start point, we can also introduce a horizontal reference line right here. I used right click and then convert to reference, and this should be horizontal, so let's give it vertical, sorry. Let's give it vertical relation. And now we can take this and make it tangent. Okay, and now it kind of worked, but something went wrong, and that is we lost 2 dimensions. That one, which should be 2, that's still almost the same, and also that one, which should be 2.5. So that was the second approach, okay? First one, remember, and of course, one approach implies the other one. Now that we have made this tangent, it automatically light the arc center on this line, and the other way around, when we light the arc center on this line, then it made this tangent. Okay, so you see, pretty easy part overall, but you can dive deep, and yeah, get into some rather advanced stuff if you want to optimize how to model that. And it could be really, really fast if you do it that way without all the explanations. And now we have that, but I want to show you that you can easily do it in different ways apart from this tip up here. That needs to be revolved. It doesn't work in another way, or at least not reasonably fast. So let's delete everything apart from that tip, because that still needs to be revolved. Go down and go here. We also need to remove that and give a 22. And what else? What do we need? Probably we need this radius, which is 7.2. 7.1, sorry. Okay, where is it? Here it is. 7.1. Okay, so it's defined. Yes, let's go. What's going on? No? Okay, like that. So we still have the tip because we would have done that in the end, of course, but I want to show you that there are obviously also different ways to do it. And one idea that I would have is make a sketch on the bottom plane right here, front it's called, and now make a circle with a radius of 5, because that's the first radius right here. Then, oh sorry, that was a diameter of 5. So I'm giving it a diameter of 10 now. So now I'm extruding that. Diameter of 10, that's our base plate. Okay. And we need to extrude that for 1 millimeter only. I'll select curve. Here we need that one. And the direction is wrong. So we have to invert it. We can do it by double clicking this arrow, for example. And here we have our first plate. Now we can sketch on top of that. Make a circle that is now 0.5 smaller on both sides, so overall with a diameter of 9. So that's now this next part. We can extrude that for 1, and then we can actually use our first circle again. Again, turn the arrow around, and now let it start at 2 and make it go until 22. No, it's not 22, we only need 20 first. And you see, this distance 2 as a start made the extrusion start here. Although our section is down here, we start with the extrusion here, and we end at 20, as it says here. And now we could take one more sketch, do it on here maybe. Make a circle with a diameter of 7.1. No, I mean 7.1 times 2, of course. Remember, you can always use... Wait. I have to change that. 7.1 times... No. 7.1. Come on. Why are there so many zeros? 7.1 times 2. And now it will calculate for me. And if I click on finish, I can now extrude that for a distance... Wait, I think I have selected the wrong one. I want this sketch. I want to extrude it. And I want to extrude it something seems off. What is going on right now? Let me try it just to make it from 0 to 5. What does it say? Because usually we would now need 2. But yeah, okay, it works. It was just weird. So from 0 to 2, because 0 is up here, and that's 2. And like that, we could have also done it. But I think it's a lot more... I mean, it's maybe something that comes to mind first for some of you, but the rotation is a way that's way more convenient and where you have more control, I guess. And also, we now have separate parts, and we still have to unite them. So let's do that. Unite. That was that one. Now we can choose this. Unite. What have we selected? Okay, that was the only unite we needed. Maybe we had some unites within the extrudes already. Yeah, we had. So our extrudes were set to unite anyways, but the one unite we still had to do, and now we know that it's a one part, because if we want to unite again and select it, then you can see we select the whole part. Okay, so that would be a second way to do it. I don't know which one you would prefer, but in the end, I think what I showed first with revolve is the better way, in my opinion at least. Okay, I hope this video could help you, and we will see each other in the next one.